Welcome to my video, What is Calculus? Calculus is the branch of mathematics that studies change, where algebra deals with numbers and relationships between them. Calculus focuses on how quantities vary, like they can increase, decrease, or move. So an example would be like in the speedometer in your car. It tells you how fast you're traveling. It's a change in position with a change in time. In business, would be like the change in your profit of your business. If sales increase, then your profit would generally increase unless your costs change dramatically. So that has to do with, there's a lot of complex relationships, but that's what calculus really is, just the study of change, how things change in nature and in the world. So the fundamental question of calculus is, how do we measure change when it happens continuously, not in steps? It's more simple if we know from point A to point B it changed by $5 or 5 miles. Then we can calculate that. But when things are changing continuously, it becomes a little more involved. And so what this ends up with, it gets down to this idea of the derivative. And we're going to see this throughout calculus. It's a fundamental idea. It's the measurement of instantaneous change. So now let's look at this average rate of change in the case where we know the start and the stop. So that's just the change in position divided by the change in time. That's going to be our average. So if we want to write S as being the function of S is going to be our variable position, T is time. So if we expand this idea of change in position, so it's the change in S at T2 minus S at T1, change in position, over T2 minus T1, the change in time. So let's look at our car example. So our car travels 120 meters in 6 seconds. So what is the rate of change? So let's draw a graph of that. Here's going to be our time axis, and our position of the car was a function of time. And we know it goes 120 meters in 6 seconds. So now our change in position divided by change in time, which we call a velocity, is equal to 120 minus 0 divided by 6 minus 0. That's 120 meters divided by 6 seconds. That gives us a velocity or rate of change over that interval. So we're looking just at this interval right here, is 30 meters per second. So there's an example of average rate of change. Now let's look at the case so what happens, so what if we want to know the position or the rate of change of the position. So we want to know the rate of change of the position as a function of time. Let's look at one particular point. T is equal to A. So graphically we can represent this, draw this little graph here. Now in this case, it's not just as simple as increasing linearly with time. Say it's changing continuously. So now we want to look at this time A, and there would be like our T1 and our T2. So over here would be S1, and then over here would be S2. I say we want to know right at this time A, right in between this interval. So we know our instantaneous rate of change, and we will look at this as T is equal to A. That's going to be the limit as delta T goes to 0 of S of A plus delta T minus S of A over delta T. So what we're doing here is we're simply contracting this interval here to make it where they just squeeze together down to this point A. And that's the way we're going to write this mathematically. We're going to take the limit as this quantity delta t goes to 0. So it's just squeezing in tighter and tighter down to a and evaluating it at a. So we can write this, and we're going to call this the derivative, or put a prime notation on there. So the rate of change of the position at a is going to be equal to the limit, and that is the delta t goes to 0. It becomes real small. The position evaluated at a plus delta t minus the position evaluated at a divided by the change in t. So what we realize is this is just the slope of the tangent of evaluated at the point A, s of t. So it's just going to be we want to draw a tangent line right here. That's where it's going to be, at that point A, s, and t. Okay, now let's do a numerical example. Let's set s of t is equal to t squared. Let's find this instantaneous rate of change. So let's go back to our formula. The instantaneous rate of change of s is s of t plus delta t minus s of t divided by delta t. Now in this case, s of t is t squared. So substituting that in, we get t plus delta t, quantity squared, minus t squared over delta t. So that is going to be equal to just doing the algebra here and expanding everything out. So we get 2t delta t plus delta t quantity squared divided by delta t, which is equal to 2t plus delta t. Just canceling that out with that, and that goes away. So we get 2 plus delta t. Now let's take the limit as delta t goes to 0. It becomes very small. We're going to squeeze this interval. So the derivative of t, the rate of change, is just equal to 2t. So if we want to know, in this example, let's just let t equal to 3 seconds. Let's see what that's evaluated at. So the derivative, or the rate of change, evaluated at t equal to 3 is just 2 times 3, and that's going to be 6 meters per second. That's at a particular point when our time is going to be, our position is changing as a square of the time. So in rate of change, it'd be like in physics, which is just what we just saw here. So the velocity is the derivative of the position, and the acceleration is the derivative of the velocity. But in biology, an example might be the growth rate would be the derivative, or the rate of change of population over time. In engineering, we look at the stress and strain on materials, and that gives us information about the material itself, how the material responds to force being applied to it. So these are just a couple of examples where you see the rate of change being used. It's used in virtually every scientific or technical discipline that we deal with. It's ubiquitous. So in summary, calculus is the mathematics of continuous change. The key idea here is the limit, which allows instantaneous change. The time is going to be squeezed down to a very small interval, and we're looking at just at a continuous point in time. So the derivative, which is a key measure in calculus, measures how the quantity changes at an exact moment. And we just saw geometrically it is the slope of the tangent line. Well, I hope you got something out of this kind of quick introduction to calculus. It's a big subject, but I think the bottom line is it's the study of the rate of change of natural phenomenon. Hope you got something out of it. If you did, give me a like and thumbs up, and thank you for watching.